Welcome everyone. This session is about lambda expressions in F sharp. Now, lambdas are functions. If you understand functions, you understand lambdas. The real difference is that functions are typically created like this. You do a let binding, you give the function a name, and then you have the parameter list, and then there is body of the function. Lambdas on the other side are nameless functions. In C sharp, those are also known as anonymous functions. So whether you use the term anonymous functions or lambda expressions, the choice is completely yours. But what you are doing is you are not creating a proper function. You are creating a function which is nameless. So let me just give you an example. And the basic format of a lambda is this. So it starts with the fun keyword. There is a parameter list. So replace all of this with fun keyword. So imagine you have let add to norms x y equals to x plus y. Replace all of this with fun keyword and replace the equals to with the arrow. And that's it. Here, this is a lambda. Now, to exemplify, I'll just use this one. 10 pass to a lambda, pass to print percentage a. Yep. Now, from the previous example, if you remember from the previous video, we were passing 10 or other numbers to add to nums and multiply and so on and so forth functions. So a lambda is a function, is a full-blown function. The only difference between a function of a full-blown function definition, a declaration, body and so on and so forth versus a lambda is that lambdas are usually in place definitions. You use lambdas when it's a one-off case. You don't need to, you use functions because functions are reusable. You create a function once and then you do whatever you have to do with the function infinite number of times. You use lambdas to simulate a function for a rarely used case. If something is to be done more than once, it's or multiple times, it's best captured in a function so that it becomes reusable. But lambdas are nothing but functions. Now over here I have a lot of examples, and to clarify what I have done is to give examples. I have created two functions in this example. So let me first of all explain what these two functions are. Now apply one takes one function as parameter and the parameter to that function, and it simply calls fx. So if you have, let's say, let add 2 to x, which is x plus 2, you can say apply 1, which is give f, which is add 2 in our case, and then the parameter for add 2, which is, let's say, 10. You will get 12, let's say, right? So what you are doing here is you have a function called apply 1 which takes two parameters. The first parameter is a function in itself, and the second parameter is the parameter to this function. Similarly, you have apply 2, which is for functions which are with two parameters. So this is one example. This is another example. Instead of a full-blown function, you can create a lambda. Which again should produce the same result, right? So there are various examples that I have given in the committed code which are based on apply 1 and apply 2 to highlight the fact that how lambdas can be. This is another example. You create a function and here is the parameter passed to that function, right? Now what I am saying is that all of these statements will produce the same result. So multiplied by 2, which is nothing but x into x times 2, x into 2. So this is the most obvious one. This is a value which is bound to a lambda. This is a function. This is a regular value bound to, and you may wonder what is a regular value anymore, because everything in F sharp is a value. So here is a lambda which is here is a function which is bound to a name. Here is a lambda which is bound to a name. So again, same effect. Lambda in place declaration, body, parameter, result. Apply 1, mult by 2, which is your regular function, and then 10. Apply mult by 2, which is a lambda here, and same effect. And then calling apply 1 with lambda. So lambdas are nothing but in place functions, nothing special. When you have a function, you can compose that function, use that function in a pipeline, you can do partial application of that function and whatnot. Similarly, once you have a lambda, you can use it for pipelining, you can use it for composition, you can use it for partial application, do whatever you have to do. One more example that I would like to give here is of what is known as closures. Now, in this example, this function is purely operating on the parameters that are supplied to it. Apply 1 is operating on f and x. Anything which is not, so let's say there's another variable declared somewhere called z. Now z is not available in this function. But let's take this example. And instead of this fixed value 2, I'm saying this lambda takes one parameter and adds whatever the value here is to num. So in this case, the answer should be 12, right? Because 10 becomes parameter x and num comes from here. Now what you have to observe here and understand, because closures are important, most of it is happening behind the scenes, so you don't have to really bother how closures work, because all the heavy lifting is done by the compiler itself. But you must understand what is going on here. So this function num is not a parameter to this function. Num is appearing inside this function as if either it's a local variable and or it's part of the global state, right? So closures are an extremely not useful. Closures are critically important for working of any functional language. Closures solve too many problems. In fact, the whole currying and partial applications are based on closures, because when you supply one parameter and you extract a function out of it, the supplied value is via a closure baked into the returned function. But that requires an intense discussion in itself, so I'll perhaps do it later. So closures are very frequently encountered in F sharp, and they are exceptionally useful in certain cases. If num was to be supplied into this function, you would have needed f of x and y, and then this num was required. Instead of 10 being passed here, you would have passed num and you would have said y, and everything is fine. So this now becomes a 2-parameter function. You pass 10 and num, but in this case you are not passing anything. You are simply saying x, which is 10 in this case, add num. So as a programmer, your life becomes very easy that closures are there. Behind the scene, how compiler does it is a completely that perhaps requires a dedicated session in itself. Not for the moment. Right now, I don't want to overwhelm you with too much information. So that's how closures work. They supply the enclosing function here, the enclosing function for this lambda is this. So the variables or the values which are part of the enclosing function appear inside the lambda as a local value. That's what a closure does. Once again, please visit the blog and read out the comments that I have placed, and so make sure you have not missed anything. See you in the next one.